Okay, so we're going to talk about infinite geometric series today. Now this also says mathematical induction, but we're going to bypass that part of it. So an infinite geometric series is just what it says, but it's the fact that instead of stopping at like a partial sum of 10 or 8 terms, we're going to keep going into infinity. So the number that we find in reality is not an exact value, but what happens is that as time goes on, it gets closer and closer and closer to a certain number. So if we look at these two tables that we have here, so we've got these two tables and the two graphs that go with those two tables. You'll notice that the graph on the left, that it goes up, and then the growth of it slows down. So it's getting closer and closer to a certain number. Where the graph on the right, this one keeps growing at an increasing rate. So we have specific names for those things, that the one on the left happens when the absolute value of r is less than 1. So if our constant ratio is less than 1, it'll do what we call converging. So this is actually, this graph on the left is converging to a specific number. Right? So it's getting closer and closer and closer to that number. And what do we call that? We have a specific name for things that get closer and closer to a certain number but don't actually touch it. Or to a certain line. Starts with the letter A. Okay. An asymptote. Okay, remember talking about asymptotes? All right, so it's kind of like an asymptote. All right, it's going to get closer and closer and closer to that number. Not actually going to get there, but it gets close. And we say that it's going to converge on a specific number. And that number that the partial sum approaches is called a limit. Okay? Now, a limit is important because it's actually a word that's used in calculus a lot. Okay? Now, if r is greater than or equal to 1, which is the case for the graph on the right, we say that it diverges. So it's going away from a certain number. Okay? So the ones on the left, if r is less than 1, it converges to a certain number, where the one on the right, if r is greater than or equal to 1, then it's going to diverge. And basically, it's going away from 0. All right? So we want to know whether a specific series converges or diverges. And so all we're looking for is r. If I know what r is, if it's less than 1, the absolute value is less than 1, it converges. If it's greater than or equal to 1, then it diverges. All right? So we just pick any two terms in the series, divide them to find the value of r, and then just look to see, is it less than 1 or greater than or equal to 1? Yep. Yep, the constant ratio is found by dividing two consecutive terms of a sequence or a series. Right? So 0.1 divided by 1 is 0.1, right? Okay. So this one has a value of r that is 0.1. That's less than 1, so we say that it converges. And then it does have a specific sum when we say it converges. Letter B. Take 12, divide by 4, and we get what? 3. And since 3 is greater than 1, it diverges, so it does not have a sum. So if r, the absolute value of r is less than 1, it converges and we can find the sum. If the absolute value is greater than or equal to 1, it diverges and we cannot find the sum because the numbers just keep getting bigger and bigger and bigger. I always like the first examples. They're always usually pretty easy. Today, though, they're actually not going to get that hard. Okay. All right. So, if don't worry about this stuff up top. Okay, that's a good explanation. So, what if I can find the sum? Okay. I need a way to be able to do that. And if you look at the part up here at the top, you'll see that they're explaining here how we can use the formula for the sum of an arithmetic or geometric series to find it if for any value of n. Okay, or I said here they're using r as 1/2. So what happens is they actually have developed a formula so that finding the sum of an infinite geometric series is actually pretty easy because it's right here. If we have an infinite geometric series, the sum is found by taking a sub 1, our starting number, our first term, and dividing it by 1 minus r. So it's a pretty simple formula. All I need to know is two things: the starting value, the first term, and the value of r. So here we have this infinite geometric series. The first term in this case is 1. And r is equal to negative 0.2 divided by 1, which I'm pretty sure that's negative 0.2. Being the mathematical mind that I am, I'm pretty sure that's negative 0.2. Don't need my calculator for that one. How about you, Lauren? No, okay. So to find the sum, I take the first term, divide by 1 minus the value of r. So 1 minus negative 0.2. So 1 divided by 1.2 is 0.83333. Right? Which is actually a really nice fraction of like 5/6, I think it is. Look at that. Now notice then on letter B that we have infinity as our value of n in this case. All right, because we're talking about infinite geometric series, so I'm just going to keep adding more and more and more and more. So to find a sub 1 in this case, we need to put in 1 for k. So we get the absolute value of 1/2 to the 1 minus 1 power. Well, what's anything raised to the power of 0? 1. Okay. So my first term, again, is real nice. It's 1. And the value of r is always what's being raised to a power. So r is equal to 1/2 here. So s is equal to 1 divided by 1 minus 1/2. Or 1 over 1/2, which is 2. So we need to find the first term, common ratio, plug it into that easy formula. Now, repeating decimals as fractions is really one of the easiest things you could ever do if you understand one thing. Okay? And here's the one thing. However many numbers repeat, you put that many 9s in the denominator. Okay? However many numbers repeat, you put that many 9s in the denominator. Okay? So, 0.63 repeating is 63 over 99. Since I have two numbers repeating, I put two 9s in the denominator, and then I just simplify the fraction. So 63 over 99 will reduce to, let's see, 9 goes into both of them, right? So that would be 7 over 11. So if I took my calculator and I did 7 divided by 11, you would get 0.6363636363 continuous forever. Okay. Can't get much easier than that, can it? So, anytime you have a repeating decimal, so let's say it was 0.527 repeating, then I would just do 527 over 3 numbers repeat, so I put 3 9s in the denominator. That's pretty simple, isn't it?